Bright Tuty. Every student matters.
Hello students, we're going to start with a new chapter today, that is cube and cube roots. We have learned so far the properties of square and square roots. Now cube and cube roots doesn't have too much of properties as we had in square roots. It has a limited number of properties. Okay, let us start with what is meant by a cube and then we will slowly reach to cube roots. Okay, so I would like to let you know what is the introduction, how did cube numbers we have started with. So I think you might know, there is a story about mathematician. If you know, there is one mathematician, S. Ramanujan, right? And one of his friend is there, he is G.H. Hardy. Okay, so this friend of his came to meet him or visit him in a taxi, and the taxi number was 1729. Okay, now Hardy declared that this number is a dull number. Okay, he said that this is a dull number, but thinking about this number of S. Ramanujan was different. He said that it is interesting, and he told one pattern about the number. He said 1729 can be written as 1728 plus 1. 1728 can be written as 12 into 12 into 12, that is 12 to the power 3, plus 1 is a cube of 1. Cube means when we multiply the number with itself 3 times. Also he told that 1729 can also be written as 1000 plus 7 to 9. Right? So what we can write that 729 is a cube of 9. So just see, we can write it as 10 cube plus 9 cube. So he expressed that there are many numbers that we can express as sum of cubes of two numbers. Right? So as he has given one pattern, there are many patterns on cube that we can observe and apply the properties in solving the questions. Let's start with what a cube is. So what are cube? You know, cube is a solid figure, right, that has the three dimensions as equal. So how to define a cube? Just to see, I multiply 1 with 1 with 1. I get 1 to the power 3. This is known as cube of 1 and the answer is 1. If I write 2 into 2 into 2, that gives me 2 to the power 3 and the answer is 8. Clear? So it is known as cube of 2. So cube of 2 is 8. The next thing that we learn here is, suppose I write 3 into 3 into 3. That gives me 3 to the power 3 and it is equal to 27. So the numbers like 1, 8, 27 and so on are called as perfect cubes. Okay, they are cube of some number. These are known as perfect cubes. Now we're going to learn certain patterns over these perfect cubes, right? Just see here. You can see the table. Cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, cube of 4 is 64. Can you tell cube of 5? It will be 125. What will be cube of 6? 6 cube, you just have to multiply 6 3 times. 6 into 6 into 6. We get 216. Now cube of 7 is 7 into 7 into 7 and that comes out as 343. Then cube of 8, that means 8 into 8 into 8 we are going to do and it comes out as 512. The next one is 9. So cube of 9 is 9 into 9 into 9, that comes out as 729 and cube of 10 is 1000. That means we observe from 1 to 1000. Between these, right, between 1 to 1000 or from 1 to 1000, there are only 10 perfect cubes, including 1 and 1000. There are 10 perfect cubes. Rest all other numbers are not perfect cubes. Clear? Similarly, we can find between 1 and 100. Just see, between 1 and 100 we have 1, 8, 27, 64. 125 is more than 100. So there are only 4 perfect cubes between 1 to 100. Right? And how many from 1 to 1000? It is 10 perfect cubes. Clear? So the number of perfect cubes is lesser than the number of square roots. And square roots we had many. Okay, just observe this thing now. Here is another table given where cube of 11, 12, 13, 14, 15 up to 20 is written, right? And what you observe here is the even numbers, right? Their cubes are even. Cube of even numbers are even. Cube of odd numbers are odd. 11 is odd, the cube of it is odd. 13, its cube is odd. Then we have 15 cube is odd. 17 cube is odd. 19 cube is odd. So whatever the odd numbers are there, their cubes are also odd, and even numbers have even cubes. Clear? So keep this thing in mind. Without actually calculating the cube of any number, we can tell whether it will be an odd or an even number. Right? Let's move ahead. Let us discuss one question here. The question says, find the ones digit of the cube of the following numbers. That means we have to calculate ones digit, but not of these number, the cube of these numbers. So how do we find that? Just see here. The first one is 3, 3, 3, 1. And you have to tell in the cube of it what will be the unit digit. Okay. So just see, take up the last digit, that is 1. Do the cube of it, you get 1 only. So the unit digit in the cube of this number will be 1. Second part, we have 8,888. If we do the cube of it, just see, you have to do the cube of 8. The last digit, the units place. 8 cube is 512. So the last digit is what? 2. So in the cube of this number, we have unit digit as 2. The next thing is the third part, which is 149. If you do the cube of 149, you just have to go with cube of 9, which is the unit digit in 149. If you do the cube of 9, you will get 729. What is the last digit? 9. So the unit digit in cube of it will be 9. Fourth part, that is 1005. If you do the cube of it, when you do cube of 5, you get how much? You get 125. So last digit is 5 only. Fifth part, we have 1024. 4 is the unit digit here. So when you do the cube of 4, 4 into 4 into 4, we get 64. So the unit digit is 4 here in this case. Now sixth part, we are given 77. If you are going to do the cube of 7, 7 cube is how much? It is 343. Right? So what is the unit digit here? 3. So we'll write 3 here. Okay, next part, that is the seventh part, 5022. If you do the cube of it, what is cube of 2? You all know it is 8. So we'll write unit digit as 8. Now the last part, what is the number that is given? 53. Cube of 53. Do the cube of 3. 3 3s are 9, 9 3s are 27. Right? What is the unit digit? 7. So unit digit in the cube of this number would be 7. So without actually solving and doing other calculations, we have done simple calculation of the unit digit. We have found out the cube of the unit digit, and that will be the same unit digit in the cube of that number. Clear? Let's move ahead now. Now we are going to observe some very beautiful patterns. Just see, there is one written here, adding consecutive odd numbers. So I would like you to observe it carefully. 1 is 1, that is 1 cube. Okay. Then after 1, what are the two odd numbers? 3 and 5. So when we add them, we get 8, and that gives us the cube of next number. Clear? Then after 5, what are the next odd numbers? 7, 9 and 11. If we add, see, first of all we just wrote the first odd number, the next two odd number, the next three odd numbers. So we are increasing the numbers. So when we write three odd numbers and we add them, we get cube of 3, that is 27. When we add after 11 the other 4 consecutive odd numbers, that is 13, 15, 17 and 19, we are getting 64, which is a cube of 4. 21, 23, 25, 27, 29, these are the next 5 odd numbers after 19. So it is giving us 125 and 5 cube. So what we are observing here, we are observing that adding the consecutive odd numbers gives us cube of a particular number. But how do you know that it will be a cube of that number, and from which odd number we need to start with? Suppose I ask for 10 cube. So how will you be answering it? That's the problem, right? So just to see, 1 cube is 1, then 2 cube is 8, 3 cube is 27. So there is a difference of 1 this side, right? And here, just to see what we are starting with, 1 is written as 1. So now if I have to start with 6 cube, let's do one question based on the same pattern. We have to find out 6 cube. Okay, so 6 cube is 216. Okay, this is what when we get it by multiplying 6 3 times. But here we don't have to answer like this. We have to just answer by using that pattern that we have observed. So let us see for 5 till what we ended up. Just see, with 5 we ended it with 29, right? But every time you won't remember the pattern. So suppose you just have to express any cube or any a number whose cube is to be expressed as the sum of odd numbers. What you need to do is, so you need to multiply these two. See, 1 into 2 is 2, 1 more than that is 3. Clear? So what I am going to do, I am going to calculate for 6, right? So I have to multiply 5 and 6. 5 6 is 30. I have to add 1 in that and I'll get to know the next odd number. Here the pattern is written. That's why you know after 29, 31 is going to come. Clear? So let's do the question. So what we are going to do, let's start it from starting. So we will write here 6 cube. So 6 cube will be starting from 31. The next odd number is 33. The next one is 35. The next is 37. The next one is 39. And the next is 41. Right? How many odd numbers do we have? 6. So it is giving us a cube of 6. When you add them, you're going to get 216. That is cube of 6. Is that clear? So what we are expressing, we are observing the pattern and writing the cube roots of it. Now let's try with 7 cube first. So 7 cube. Now at what the 6 cube has ended? 41. So also you can just check 6 sevens are 42. Just add 1 in that. So from 43 we have to start. 43 plus what is the next one? 45. The next is 49. Next is 51. Next 53, and after 53 we have 55. Have we done 7? 1, 2, 3, 4, 5, 6. So 55 plus 57 will also come up. When we add them, we get cube of 7. What is cube of 7? It is 343. Now cube of 8. Okay, 8 sevens are 56. Yes, the one next. Okay, let us count how many we have done. 1, 2, 3, 4, 5, 6, 7. Are we leaving any one? 43, then 45, then 47. Okay, 47 we have left here. 47 will come up. 49 will come up. Then after 49 which will come? 51. After 51, 53 and 55. So these are the odd numbers that we write, and when we add them we get 343. So see, when I was doing for 8, I got to know the mistake done, right? Otherwise what you would have done, after 57 you would have started, right? So 8 sevens are 56, add 1 to it, that is 57. So we'll start with 57. The next one is 59. Next one is 61. The next is 63. The next is 65. Then 67. And then what is there? 69. Are we done with 8? 1, 2, 3, 4, 5, 6, 7. One more we need to write. We will write next one 71. When we add all these numbers, we get cube of 8, that is 512. So just by noticing the pattern, we are able to write the cube of numbers. Clear? Also you could do, because it is asking based on the pattern above, we are writing that. Otherwise we can just multiply 6 3 times, 8 3 times and 7 3 times and we can write it. Clear? Let's move ahead. Here is another pattern. Okay, you have to observe it and answer the following question that are given here. So let's observe the pattern. 2 cube, 1 cube, whether 3 cube, 2 cube, 4 cube, 3 cube, right? Whenever we are going to subtract the cube of consecutive numbers, just to see this 1 is same in all. This 3 multiplication by 3 is also same in all. What is different? It is 2 into 1, 3 into 2, 4 into 3. How do we get this? Just see 2 into 1, they have multiplied the two numbers. 3 into 2, here they have multiplied the other two numbers. 4 into 3, they have multiplied the other numbers. Right? So what we are doing, the pattern is such that if we have a cube minus b cube, the pattern is written 1 plus, and here multiplication of 3 is there in all. What is the difference? 2 into 1, and 2 into 1 is what? A into b here. Clear? So using this pattern, we are now going to find out 7 cube minus 6 cube. So we have to write 1 plus into 3 also we have to write. What is A and B? A here is 7 and B here is 6. So here also multiplication of the numbers is there that we have written. So what we will write? 1 plus. Now we have 7 6 are 42. 42 into 3. 3 2s are 6, 3 4s are 12. We get 126. When we add 126 to 1, we get 127. Right? I'm repeating it again. What we have done? 1 plus into 3. This is compulsory to write. It is there in all the parts that are given as a pattern. And between we have to multiply A and B. So A here is 7. B here is 6. 7 6s are how much? 42. And we are multiplying it with 3. 3 2s are 6. 3 4s are 12. We get 126. So the answer is 127. Now the next part that we have to solve, this was the first one. The second part that we have to solve is 12 cube minus 11 cube. So what we will write? 1 plus 12 into 11 into 3. Yes, let's multiply them. 1 plus 12 into 11 into 3. 11 into 3 you know is how much? 33. So we will multiply 12 with 33. Okay, or I can write it like this so that the multiplication is much easier. 12 3s are 36. A carry over here is 3. 12 3s are 36 and 3 39. We get 396. Add them, we get 397. Clear? Similarly, we can perform third and fourth part. Okay, let's do third and fourth part. So in the third part, we have been given 20 cube minus 19 cube. So we will write 1 plus 20 into 19 into 3. Clear? So let's multiply 1 plus. Now just see, 20 into 3 gives us 60. 60 multiplied with 9. So 90 is to be multiplied with 60. Right? We'll get 0 0. 6 9s are 54. Carry is 5. 6 1s are 6 and 5 11. So we get 0 0 1 1 1 4 0. 1 1 4 0. When we add them, we get 1 1 4 1. Clear? So what we have done? 1 plus 20 into 19 into 30. 20 into 30 is how much? 60, and 60 is to be multiplied with 90. So we got 0 0 here. 6 9s are 54 and carried 5. Then 6 1s are 6 and 5 is 11. Clear? So let's move now to the next question, which is the fourth part. 51 cube minus 50 cube. So we'll write 1 plus, okay, 51 into 50 into 3. So what we get? 1 plus. Now multiply. 53s are 150. So 150 is to be multiplied with 51. Let us do that. 1 0 0. 1 5s are 5. 1 1s are 1. Now with 5 5 0 0. 5 5s are 25. There is a carry here over 2 over 1, that is 2. 5 1s are 5 and 2 7. So we are getting 0 5 6 7. 7 6 5 0 we got. When we add them, we get 7 6 5 1. Right? So what we have observed? The pattern, and based on that pattern we have solved the question that we were asked to solve. So now we will learn about cubes and their prime factors. We have done squares and their prime factors. Now we will learn about cubes and prime factors. So we know now what is a cube, right? When we multiply a number 3 times. So here suppose I say, I am writing here 8. Okay, or let's start with a very simple number. Let's take it as 4. Okay, what are the prime factors of 4? It is 2 into 2. Let's take cube of 4. Cube of 4 is 64. Okay, and let us do the prime factorization for 64 and make a small observation here. 64 I am writing here. Let's start dividing with 2. 2 3s are 6, 2 2s are 4. Again 2. 2 1s are 2, 2 6s are 12. 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 2s are 4, and 2 1s are 2 we have. So we see in 64 how many times 2 is coming? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. What do you observe here? Here 2 is coming 2 times. This side it is coming 6 times. So this 2 we can write it as 2 to the power 3. If we form this is 2 to the power 3 and this is 2 to the power 3. So in these two, they were single 2's and we have written as the power of 2 as 3 in both of them. So what is happening that in the cube of any number, or we say in the prime factorization of cube of any number, the number will come 3 times as it come in the number itself. So in 4, the prime factors were 2 and 2, but in cube of it, the prime factor is 2 cube into 2 cube. That is, it is coming 3 times. Okay, so we will use this. That means we are going to find in this not pairs, we are going to do triplets. Selection of these 3 making a 3 combination is known as a triplet. So what we will do to find out the cube, we will do what? We are going to do the triplets. We are going to form triplets of the prime factors that we get, and then from them we are going to 1 1. Take 1 and 1. Clear? So let's try some questions and this will be much clear to you. So here they're asking, is 243 a perfect cube? If all the prime factors are forming triplets, then that number would be a perfect cube, otherwise not. Let's start with this number 243. So 243, is it divisible by 2? No. Let's start with 3. 3 8s are 24, 3 1s are 3. Now again 3 2s are 6, 3 7s are 21. Again 3 3 9s are 27, 3 3s are 9, 3 1s are 3. Just see, 243 is expressed as how many times 3? 5 times 1, 2, 3, 4 and 5. We have 5 times 3. Let us try to form the triplet. One triplet is this one, but this is forming a pair, not a triplet. That means here it is left. This 3 cross 3 is not coming into the triplet. It is not forming a combination of 3 threes. So we say that this is not a perfect cube. Not a perfect cube. Is that clear? This is how we recognize whether a number is a perfect cube or not, and prime factorization is the only method you can do in to find out whether a number is perfect cube or not. Clear? So let us do another one. Here are some questions and they're asking us which of the following are perfect cubes, right? So you just have to do the prime factorization one by one and we'll get to know which one of them are perfect cubes and which one of them are not. So the first one that we see here is 400. Let's try and do the prime factorization for 400. We'll start with 2. 2 2s are 4, 0 0. 2 1s are 2, 0 0. 2 5s are 10 and we are going to copy this. Then again 2 2s are 4, 2 5s are 10. Then 5 5s are 25. So 400 is expressed as how many times 2? 4 times 1, 2, 3, 4. And then we have 2 times 5. 5 cross 5. So let's form the triplet. One is this. We can't form a triplet with this, and this is also left unpaired. It is not getting combined with any of the triplet. So we see that this is not a perfect cube because here we are not getting all the triplets, right? The prime factorization are not converted into triplets, so it is not a perfect cube. Clear? So I'll just write the answer. No, 400 is not a perfect cube. Right? Let's try the second one. that is 3375. 3375. Okay, so let's do the prime factorization with it. So with 2 definitely it is not divisible. Let us try with 3. 3 ones are 3, 3 ones are 3, 3 twos are 6, and 3 fives are 15. Now again with 3, 3 threes are 9. Okay, then we have here left 2. 3 sevens are, then we have 21, 3 fives are 15. Again with 3, 3 ones are 3, 3 twos are 6, 3 fives are 15. Okay, now it is not divisible with 3, it is divisible by 5. 5 twos are 10, 5 fives are 25. 5 fives are 25 and 5 ones are 5. So 3375 is written as 3 cross 3 cross 3 cross 5 cross 5 cross 5. So let's form the triplets. This is the first one and this is the second one. Yes, both the prime factors, that means 3 and 5 are the two different prime factors and they are forming triplets. So yes, 3375 is a perfect cube. Right, so like this you will be recognizing. So we are going to do one by one each and every part. So any one of you have any problem in any question can match the solutions here. Okay, let's start with the third one, that is 8000. 8000 start with 2. Okay, 2 fours are 8 and zeros will be as it is. Then 2 twos are 4, we're going to get 2000. Then again with 2 we get 1000. Again with 2 we get 500. Again with 2 we get 250. Now again with 2 we get 2 ones are, 2 twos are, and 2 fives are. Now it is not divisible by 2 and 3. It is divisible by 5. 5 twos are 10, 5 fives are. Then again with 5 we will have. So we have like this. Okay, so 8000 is written as, how many times do we have? 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, and 5 is coming up 3 times. 1, 2, 3. So this is one triplet, this is another triplet, this is the third triplet. Yes, we are able to form or convert all the prime factors in the form of triplets. That means a group of 3, 3. So yes, 8000 is a perfect cube. Right, so just write down 8000 is a perfect cube. Clear? Now we will do the next question, that is the fourth part. I hope questions are clear. In the fourth part we are given 15,625. Let's start dividing it. So can we divide it with 3? Let us try. 3 fives are 15, 3 twos are 6. No, it is not divisible by 3. Let's start with 5. 5 threes are 15, 5 ones are 5, 1 is left, it became 12, 5 twos are 10, now 2 is left, 5 fives are 25. Again with 5, 5 6 are 30, 1 is left, 5 twos are 10, 2 is left, 5 fives are 25. Again with 5, 5 ones are 5, then 5 twos are 10, 2 is left, 5 fives are 25. So 5 twos are 10, 5 fives are, again 25 divisible by 5 and 5 is divisible by 5 itself. So 15,625, that means 15,625 can be written as 5 into 5 into 5 into 5 into 5 into 5. So can we form the triplets? Because see, 1, 2, 3, 4, 5, 6 is there. So we have written 1, 2, 3, 4, 5, 6 times 5. Form the triplets of 3, 3. Just see. Yes. So yes, we are able to form the triplets. So we'll say yes, 15,625 is a perfect cube. Clear? So I hope the questions are giving you more clarity how to get to know that whether a number is a perfect square or not. So let's try the fifth one now. So in the fifth one we are given 9,000. Okay, let's start with 2 because it's an even number. 2 fours are 8, 2 fives are 10, 0, 0. Again with 2. 2 twos are 4, 2 twos are 4, 2 fives are 10 and 0. Then let us again try with 2. 2 ones are 2, 2 ones are 2, 2 twos are 4, 2 fives are 10. And again with 2. Is it divisible by 2? It is not divisible by 2. So what we are going to do, we are going to try with 3. So if we try with 3, we will get 3 3s are 9, then 2 is left, 3 7s are 21, then 1 is left, 3 5s are 15. Now again with 3 we can try it. 3 1s are 3, 3 2s are 6, 3 5s are 15. Again with 3 we can write, can we try with 3? No, we'll try with 5. 5 2s are 10, 5 5s are 25, 5 5s are and 5 1s are, like this. So 9000 can be expressed as how many times 2 is coming up? 3 times. How many times? Then 3 came 2 times. And how many times 5 is coming up? 3 times. Clear? So what we did, I divided 9000 with 2, then again it got divided by 2 3 times, then 2250 we got 1125, and we have divided it with 3, 3 is a 9, then 2 is left, 3 sevens are 21 and 3 5s are 15. Again with 3 we try, and then with 5 let's try to form the triplets. This is one triplet, this is another triplet. Can this form a triplet? No, this is forming a pair, not a triplet. A triplet has 3 in them, right? 3 numbers in them. So we say no, 9000 is not a perfect cube. Right, so we are able to reach on to the conclusion by forming the triplets. Whether a number would be a perfect cube or not can be known by prime factorization very easily. So now we will try the next one. The sixth part is 6859. Let's start dividing it. We observe that this is not divisible by 2, not even by 3, not by 5, not by 7, not by 9. Try it out. 11 also it is not divisible, not with 13. Okay, it is divisible by 19. Let's divide it with 19. So we get 19 3s are, 6 are and 1. Again with 19 it will be. So we get 19 and 19. Right? So we see that 6859 can be expressed as 19 into 19 into 19. That means it's a cube of 19. So yes, 6859 is a perfect cube. Clear? So you keep on dividing and see with which number it would be divided. Now let us try the seventh one. In the seventh we are given 2025. So let's start with 3 and then with 5, because 2 it wouldn't be divided. With 3 we will, if we divide with 3 we will write 3 6 are 18, then 2 left. Yes, it is divided. 3 6 are 18, then 2 is left, 3 7s are 21, then 1 is left, 3 5s are 15. Again with 3 3 2s are 6, 3 2s are 6, 3 5s are 15. Again with 3 3 7s are 21 and 3 5s are 15. 3 2s are 6, 3 5s are 15. Then with 5 5 5s are 25. So we see 2025 is written as 3 is coming up 4 times and 5 is coming up 2 times. So only one triplet is formed. The rest are left, right? They are not, we are not able to form the triplet in them. So we say no, 2025 is not a perfect cube. Clear? Now the last part, which is question number 8, let's try that also in the similar way. 10,648. So we're going to try it with 2. 2 5s are 10, 2 3s are 6, 2 2s are 4, 2 4s are 8. Again with 2, we have 2 2s are 4, then 2 6 are 12, 2 6 are 12 and 2 2s are 4. Let's divide it again so that we are at no mistake. 2 2s are 4, then 1 is left, 2 6s are 12, then 1 is left, 12, 2 6s are 12 and then 2 2s are 4. Again with 2, 2 1s are, 2 3s are, 2 3s are, 2 1s are. Now 1 3 3 1 is not divisible by 2. It is not even divisible by 3, not by 5, not by 7. Let's try it with 11. So 11 ones are 11, 2 are left, 11 twos are 22 and 1 11. Yes, again with 11, 11 ones are 11 ones are. So again with 11 we have. So 1 0, that means 10,648 can be written as 2 is coming up 3 times and 11 is also coming up 3 times. So yes, we can form the triplets. Okay, these are forming the triplets. So we say yes, 10648 is a perfect cube. Yes, so this is how we calculate and come to know which of the following numbers are perfect cubes using the prime factorization. Clear? Let's move ahead now. Here, now we will discuss smallest multiple that is a perfect cube. So we are going to take one example and then we'll come to know what is that smallest number that we should multiply with our number so that it becomes a perfect cube. So I'll take one example. Suppose you have a cuboid, okay, and the dimensions are 15, 30 and 15. Now you want to make a perfect cube from it. Okay, so what is the volume of it? What will be the volume that we know? It will be length, breadth and height. So 15 into 30 into 15. Okay, so let's see, because we have to make a perfect cube, the product should also be a perfect cube. Now 15 can be written as 3 into 5. Okay, 30 can be written as 15 into 2, or in the prime factorization 30 can be written as 2 into 3 into 5. 15 is 3 into 5. So how many 3's we have? 1, 2, 3. Let's write them collectively. How many 5's? 1, 2, 3. So 5's also writing together, and we are left with 1, 2. So these are forming the triplets, but here in the prime factorization we have only 1, 2. Right? Now to make it a perfect cube, we need to multiply it with 2 more 2's, so that it also forms a triplet. So this is the number, that means 2 cross 2 we are adding into it. 4 more cuboids you need of these dimension, so to make a perfect cube. Right? How many cubes? 4 more, 4 more cuboid you need to make this cube. Right? Let's perform one question. Let's do one question to apply the same concept in that. Okay, just see here. It is asking, is 392 a perfect cube? Let us first check it. 392. Starting with 2. 2 ones are 2. 1 is left. 2 nines are 18. 2 six are 12. Again with 2. Now how to write? 19 is there. 2 nines are 18. 2 eights are 16. With 2, 2 fours are 8. 2 nines are 18. And then we have 7 sevens are 49. Okay, so we have divided it. We got 49, right, and it is divisible by 7. So 392 can be expressed as 3 times 2 and 2 times 7. Right, so 3 times 2 and 2 times 7 we are writing. Forming the triplet, only one triplet is formed. So we say it is not a perfect cube. It's not a perfect cube. Okay, now they're asking, if not, find the smallest natural number by which this should be multiplied so that it becomes, that means the product becomes a perfect cube. Now what we are missing in this to form a triplet? 1, 7. So we will multiply both the sides with 7. Just see, here we will get 2 cross 2 cross 2, that is one triplet, and here we already have 7 cross 7, we will multiply with one more 7. So here we are having 2 cube and 7 cube. Right, so it is not a perfect cube, but we are making it a perfect cube by multiplying it with something, and that something is 7 here, because we are missing out 7 here. Okay, let us multiply here 392 with 7. 7, let us do it here in the rough part. So 7 twos are 14, 1 will be the carry here, then 7 nines are 63 and 1 is 64, 6 is the carry over here, then 7 threes are 21, 21 and 6 is 27. We get 2744, right? So the number which is a perfect cube is 2744. So first of all, we recognize whether it's a perfect cube or not, and then we reached on to the conclusion that it was not a perfect cube. Then we were asked to find out the smallest natural number by which this should be multiplied to convert it into a perfect cube. So that number is 7. Okay, this is how you're going to attempt the questions. Let's move ahead. Here also there is one question. In this case also, first of all, we have to check that 53,240 is a perfect cube or not. So let's check 53,240. Starting with 2. 2 twos are 4. 2 6 are 12. 2 6 are 12. 2 twos are 4 and 0. Now with again 2. 2 ones are 2, 2 threes are 6, 2 threes are 6, 2 ones are 2, 0. Now again with 2, 2 6 are 12, 2 6 are 12, 2 5s are 10, 2 5s are 10. Now it is not divisible by 2. Is it divisible by 3? It is not. Now let's try with 5. 5 ones are 5. How much are left? 1. It is becoming 16. 5 threes are 15. 5 threes are 15. 5 ones are 5. Now in the previous only we have done 1 3 3 1 was divisible by 11. So 11 ones are 11 twos are 11 ones are. And again 11. So we are getting 11 three times. So 53240 53,240 can be written as 3 times 2 multiplied with 5 multiplied with 3 times 11. Let's form the triplet. Yes, we are able to form two triplets and 5 is left alone here. We are not able to form triplet with 5. So they're asking what is the, this is not a perfect cube, right? So we'll write not a perfect cube. Now they're asking, if not, then by which smallest natural number this should be divided so that the quotient is a perfect cube. So what we are going to do is, we'll divide with what? 5, because if we remove this 5, this will become 2 cube into 11 cube, and that's a perfect square. So let's divide both the sides with 2. Dividing this side by 2 and dividing not with 2, with 5. Sorry, it is 5. So here 2 cross 2 cross 2 into 5 cross 11 cross 11 cross 11 divided by 5. 5 and 5 here will get cancelled, and this side we just have 2 cube into 11 cube. Let's divide it with 5. 5 ones are 5. 5 ones are 5. Now 3 is not divisible. We'll place a 0. Then 32. 5 6 are 32. 2 is left. 5 4s are 20. Then 4 is left. 5 8s are 40. We get 10648. Right? And this is a perfect cube. Correct? So which is the number that we should divide it with? 5 is the natural number that we should divide this number to get a perfect cube. Clear? Now here is one more question. Okay, we are going to practice it. It is saying 1188 a perfect cube. Let's try with 1188 and check whether it's a perfect cube or not. Starting with 2, we have 2 5s are 10, then 1 is left, 2 9s are 18, 2 4s are 8. Again with 2, 2 2s are 4, 2 9s are 18, 2 7s are 14. Now we have 297. Is it divisible by 2? No. With 3, let's try. 3 9s are 27, 2 is left, 3 9s are 27. And again with 3, 3 3s are 9, 3 3s are 9. Then we will divide again with 3, we get 1 1. That means 11 is the last number. Okay. So just to see what we have, 1188, and we can write it as 2 cross 2 cross 3 cross 3 cross 3 cross 11. So only one triplet is formed. So it's not a perfect cube. It is not a perfect cube. Okay, now we have to tell with what it should be divided so that it becomes a perfect cube. So we have to finish this 11 and this 2 into 2. So 2 into 2 is 4, 4 into 11 is 44. The number that we should divide with this is 44 so that it becomes a perfect cube. So let us divide both the side with 44. Okay, so here also when we divide with 44, 11 into 2 into 2, just see 2 into 2 into 3 into 3 into 3 into 11. Divide by what? 44. 11 ones are, 11 fours are, 2 ones are, 2 twos are, and this will get cancelled. We will just be left with cube of 3. This we are left with here. Okay, cube of 3, can you tell me what is it? It is 27. So when you cancel it, you are going to get 27. So what is this number? 1188. We did the prime factorization and reached to a conclusion that we cannot say that it's a perfect cube. Then we saw that what are the numbers which are not coming into the triplet, that is 2 into 2 into 11, that's 44. So we divided this number with 44 and got a number that's a perfect cube. Clear? So I hope this is clear, and let's do one more question. Here is a number given and they're asking, is this a perfect cube? We are given 68,600. So divide it with, start with 2. 2 3s are 6, 2 4s are 8, 2 3s are 6, 0, 0. Right? We are dividing with 2, 2 3s are 6, 2 4s are 8, 2 3s are 6, and double 0 we have at the end. Again with 2, 2 1s are 2, 2 7s are 14, 2 1s are 2, and then we are left with 1, 2 5s are 10, 0. Again with 2, 2 8s are 16, 2 5s are 10, Then 1 is left, 2 sevens are 14 and 2 fives are 10. Now let us divide with 5. It is not divisible by 3. So we do with 5. 5 ones are 5, 3 is left. 5 sevens are 35, right? Listen it carefully. With 5 we are dividing 8, 5, 7, 5. So 8, 5, 7, 5 when divided with 5. 5 ones are 5. Now you will be left with 3. Copy down 5. 5 sevens are 35, right? Remainder is 0. Now you will copy 7. Is 7 divisible by 5? Yes. 5 ones are 5. 2 is left. Then 5 fives are 25. So we get 1, 7, 1, 5. Clear? Now again with 5. 5 threes are 15, 2 is left, 5 fours are 20, 5 threes are 15. Now 3, 4, 3 is there. It is not divisible by 5 also. Let us try with 7. Okay. 7 fours are 28 and then we have 7 nines are 63. Again with 7. So we are getting it like this. So 68,600 can be expressed as 2 cross 2 cross 2. 2 is 3 times. 5 is 2 times and 7 is 3 times. Can you form the triplets? Yes. Here is this triplet, here is this triplet. What we are missing? 1, 5. Now they are asking, is this a perfect cube? No. It is not a perfect cube. Okay. If this is not a perfect cube, then what about the number that it should be multiplied with so that it becomes a perfect cube? What we are missing here? We are missing a 5 here. If we insert one more 5, then it will also form a triplet. So we can multiply this number 68,600 with 5, and this side also we'll have 2 cross 2 cross 2, then 5 cross 5 cross 5 because we are adding one 5 into it, and 7 into 7 into 7. Just see, 3 triplets are formed. So what is the number that will be a perfect cube? Let us multiply 68600 with 5. 68600 with 5. 5 0 0 5 0 0 5 6 are 30. We're going to take the carry of 3. 5 8s are 40 and 3 is 43. Take a carry of 4. 5 6 are 30 and 4 34. So we get 3 4 3 0 0 0. So this is a perfect cube now. Clear? So this is how we find out. I hope the question and the concepts are all clear to you. So this is all for this lecture, and we'll continue our chapter. We'll practice some more question based on cube, how to find out perfect cube, what should we multiply and divide it, so that we have a good practice of it and we master the concept.